Okay, I think that I don't have that topics over here. Pretty much I'm trying to do over here is trying to incorporate the mathematical and statistical flavor for the research. That's something very important. And especially this one that this talk that I have taken from that my master level classes. This is how I'm doing my master level classes, because pretty much I just go through all the research papers rather than using a textbook. In that way, I can train them very well so that they can easily go for a PhD or beyond that. So here, if we go over here, you can see that I'm trying to think about that some kind of like a multi-component system. That component system may be like a kind of maybe electrical, electronics, or maybe physical, any kind of a system that its reliability, how the reliability should be tested using statistics, heavy statistical approaches. So in order to do that one, we are just thinking about multi-component. For instance, I can think about something like this, that the bridge, suspension bridge, is hung by like several cables. Even though these cables are over there, there might be like 1,000 cables that you don't have to have a strong 1,000 cables for that bridge to withstand for the erosion, corrosion, or wind or any kind of a cracks. You need a certain number of cables to be very strong, at least certain number. That's been that the model into like a statistical model over here. This is a little bit heavy, okay? But what I'm trying to do is I just mainly go through that pretty much that the core part, which is that what this is for, and I'm using instead of the complete data, I'm using the incomplete data, like a censored data, and I'm going to go straight to a practical application. That's what I'm trying to do over here. So if you go ahead and look at this one, you can see that where we can use this multi-component system. Multi-component system is heavily utilized in bridges, V8 engine, electrical power station, and communication system, and semi-trailer, even in like a big trailers that you don't need too many tires. That is, there are certain number of tires are more than enough for that trailer to pull over and then move forward. And in that multi-component system, how could we gonna talk about the reliability? How reliable that system? That reliability has to be tested through the statistical procedures, methodology, and the methods at the end of the day. In this scenario, what we did was that we have like two types, like a stress and strength. Stress means like that's something you're going to exert from the outside. Strength means like the system has a certain strength to withstand that kind of like a stress from outside. There are several stresses being modeled with different kind of a distribution. This is not a conventional distribution. This is very heavy distribution. General class of exponentiated, inverted exponential distribution. That's not like a very conventional, but it's a part of that Weibull family. So once you model this one, this is our reliability. This whole expression. This part would be your reliability at the end of the day. Now, my core part of my talk would be how to do the statistical analysis for this reliability component. Through which framework? In order to do this one, this is going through this heavy stuff. And in addition to one thing I have to add over here, in this particular scenario, I'm not going to get a complete data. Normally, we have a complete data. But in practical application, there's no way that you can get a complete data. They were censored. How censored? Let's say that, for instance, that you have a... Is that enough? That's all? I don't think that math and stat, I cannot do a research like this here. Very heavy. I'm so sorry about that. You missed the core part. Okay, thank you.